All right, cycloalkenes and cycloalkynes. So again, just like cycloalkanes, they're going to be a closed ring structure. Okay, but there'll be a double or triple bond somewhere in that closed ring. Okay, really, cycloalkynes don't really form cyclic, or like really aren't that big of a thing. But for us to draw one, you just follow the same rules as cycloalkanes. Okay, the naming of cycloalkanes with side branches. The numbering for the parent chain always starts with the double bond. So you never have to say where the double bond is in a cycloalkene or alkyne. You know that this is carbon 1, carbon 2, and then it goes on. Again, so if we only add the numbers if we have methyl and ethyl groups. Okay, so carbon double bond are between carbons 1 and 2. Cycloalkanes are isomers of alkenes with the same number of carbon atoms and both have the same general formula. So isomers mean that they have the same molecular formula, so the same number of carbons and hydrogens, but just different structures. So they can be like an alkene, so C5H10 could be a cycloalkane or just a long 5-carbon or just a 5-carbon chain with a double bond somewhere in there. Okay, cycloalkenes are isomers of alkynes with the general formula CnH2 and or it should say 2n minus 2. Okay, if you find several structures have the same formula but different names, okay, those are what we call isomers. Okay, and so really, like as far as cycloalkenes and alkynes, for naming them, your parent structure is always the chain. Your numbering always starts where the double or triple bond is. Okay, and so like for this one here, we have a 6-carbon chain, so it's going to be cyclohexene. Okay, and then we're going to number it so that we get the lowest number at the branch. So this would be carbon 1, 2, 3. So we got 3-methyl cyclohexane. Okay, aromatics. So now, the first three, so alkenes, alkynes are aliphatic hydrocarbons. Aromatics are their own kind of separate types. So they're a type of hydrocarbon that looks like a typical cyclic hydrocarbon, but has unique properties because of what we call a benzene ring. Okay, and so yeah, they're hydrocarbons derived from the benzene ring. So somewhere in their structure, they have to have a benzene ring. Okay, and we'll talk about that. So benzene ring is a 6-carbon ring with 1 hydrogen atom that's bonded to each carbon. Okay, so the general formula, well, the only formula, C6H6. Sometimes, like if you see C6H5, that means that your benzene ring is bonded to something else. Okay, the melting point for benzene is 5.5 degrees Celsius. Okay, the boiling point's 80.1, so benzene is a liquid at room temperature. It's nonpolar, again, just C's and H's. Chemists realized that benzene was a resonance hybrid where the electrons that make up the second bond in the double bonds are equally shared between all the 6 atoms. So really, these, like when we're drawing structures, we have these extra electrons in here. So what they do is form a double bond, but what they found is like the double bond continues to switch from this carbon over to this carbon and so on all the way around. So a way that we kind of show that is by showing this circle saying this double bond is continuing to switch. And so yeah, electrons behave in this way because they're what we call delocalized electrons. They aren't always in this place forming this structure. It's just as likely they'll be over here forming this structure and so on. So based on this information about the structure, chemists now prefer drawing the benzene ring with single bonds between carbon atoms and then a circle within the carbon ring to represent the 6 delocalized electrons. So this is kind of the preferred way. Just one thing to note, like if you're asked to draw the structural diagram of benzene, this is what it would look like. Or you can flip it, like either one of these is equally as likely. Okay, if you're asked to draw the condensed structural, you just put the H's beside the C's. The line structure is this one, okay, but make sure you're using the proper one that it asks for. So naming aromatics, okay, has its own rules, just like it naming alkenes, alkynes, alkanes. Okay, so since benzene forms the basis of all aromatic hydrocarbons, okay, the naming of simple aromatic hydrocarbons uses benzene as the root. Okay, so really what we look for, the root's going to be benzene, okay, and then we start our numbering with the presence of any side group. So if there's only one side group, we don't need to number it. It's just going to come off of the one side, because really we're just, so yeah, if there is more than one group, then we add the numbering in. Okay, the numbering starts at the carbon with the highest priority or the most complex group. So the highest priority are like these. So like if we have an OH group, which we'll talk about later, okay, or NH2 or any of the halogens coming off, okay, but if it's just an alkyl group, then we start in alphabetical order. And so the numbering goes in like, so if there's an ethyl group, you would start the numbering there before the methyl group and so on. Okay, and then you start the numbering so that you get in the direction of the nearest group, so you have the lowest possible numbers. If a benzene ring is attached to a single hydrocarbon chain as longer than the benzene ring, so if it has more than 6 atoms, then the benzene ring is considered a substituent group, and so we call it a phenyl group. So like in this case, we have 1, 2, 3, 4, 5, 6, 7 carbon chain off the third. So like this would be heptane, and then off their third carbon is a benzene. So we'd say 3-phenyl heptane would be the name of this structure here. Okay, but if it's just coming off and it's smaller, if we have more in one group, then this would be 1,2-diethylbenzene. Some properties, okay, we already talked about melting point and boiling point. Okay, it's a symmetrical structure. It allows for stacking, which contributes to a higher melting boiling point compared to like alkenes, alkynes, and alkanes. So some practice here. So we'll name a couple. So for this one, okay, so there's no chain that's longer than 7. We just have a 2-carbon chain and 2 different 1-carbon chains. So benzene is going to be our root. Okay, now we start our numbering with our ethyl group because it's in alphabetical order. So this would be 1-ethyl, 2,4-dimethyl benzene. Okay, for this one, okay, this, when it puts it like this, it's just saying like we have a whole bunch of CH2 groups, so we have 3 of them. So instead of writing them all out, we just put them kind of grouped together. So this would be 1, and then it'd be 2, 3, 4, 5, 6, 7, 8. So we have an 8-carbon chain. Okay, and then this is a propyl group because it has 3 carbons. Okay, and then this would be our phenyl group. So for numbering, we're going to start from this side to get the lowest number, 1, 2, 3. And then phenyl would be in front of propyl, so it'd be 3-phenyl, 4-propyl. And we said 1, 2, 3, 4, 5. So 8. So octane. So 3-phenyl, 4-propyl, octane. Okay, down here, this one, okay, we have 2 different, these are ethyl groups coming off. So it'd be 1,3-diethylbenzene. This one we have a methyl group and a propyl group. So it'd be 1-methyl, 4-propyl benzene. And then here, 1, 2, 3, 4, 5, 6, 7. So we have 3-phenyl heptane. Okay, when we're drawing them, we look at the end of the name given to identify the parent chain. Okay, if it has benzene in the name, we start by drawing the benzene. So like in this case, we'd start with benzene. Okay, this is probably going to be hard to draw here with my mouse, but we'll see what. And it's asking for the line structure, so I don't need to draw like each carbon. Okay, so there's my benzene. Okay, and then coming off the first one, we have an ethyl group. Okay, and so line structure of ethyl looks like that, because there would be one carbon here, one carbon here. Okay, and then 3-methyl. So that's the thing, you don't always have to start here. I just, wherever I put my ethyl group, that's number 1. So then 2, 3, this is my methyl group. So just a straight line coming off. Okay, so there we go. That would be 3-methyl benzene. Okay, if you want more examples again, just let me know, and I'll do some more examples.